Hi students, this is the first problem in the second unit. What's the problem? A simple cantilever frame is loaded as shown in figure. Find the forces and their nature in the member A, B and BC by method of joints. Here look at the diagram very carefully. Here one cantilever trusses which is given the problem very clearly. So cantilever means already you know, right? One end is fixed, other end is free. This kind of trusses is called a cantilever truss. Okay. So the span of the truss is 5 meter. We know that the span, right? And the angle of inclination of this inclined member is 30 degree. And one point load which is acting at the joint B. Clear? So the load is 15 kilonewton. So we know all details are given the problem very clearly. Here we should find the forces and nature of forces. Okay, forces and nature of forces of these members. That means AB and BC. Okay, because of this load, what should we find from this problem? Because of this load, how much force which is carrying this particular member AB and BC, and what kind of forces, that means which is a tensile force or compressive force, that is the nature of force, what kind of force is acting on this member. Okay, that's the concept. How can we find the force of each and every member? So it's a very simple, just already you know the procedure, right? For the cantilever we can directly take the joint, no need to find any support reaction. Okay, what will you do? First of all, for your reference just draw it, because we are going to cover this joint only, okay, not the other part. Just for your identification, make the make this just rectangular or square, whatever it may be, just cover this area, this joint. Okay, just write like this: take joint B. Then you just draw the free body diagram of this joint. Okay, free body diagram is nothing, just you are going to draw at that particular joint. First of all, draw like this, mark all data which is given the problem. This is the 15 kilonewton load, you know, this is the B joint, right? Name of the joint is B. This angle of inclination is 30 degree. Okay, this is the first step. First of all, what should we do? First of all, draw free body diagram of that particular joint. Second step, just mark the direction of force. Direction of force means we don't know exactly what kind of forces are acting over there. Just we are going to assume tension force. This is our assumption. We don't know exactly what kind of forces are acting over there, but our assumptions. Okay, we assume that this is a tension member, this is also, that means the tension force is acting over here. That's the concept. Okay, then third step. What is the third step? Give the name of the member. How will you give the name? You can write like this: P means that's a force, or F, whatever it may be. P, B, the first letter mentions the joint, second letter is A, that means towards its joint. Okay, that's a point. So B means this first letter B represent that joint. Okay, which joint we are taking, that's a B. A means this member where is going. Okay, similarly we can provide another member name P B C. Can you understand? So P B C. B means P is the force, you can write the letter F or P, whatever it may be. B is the joint, C is the towards which joint. Okay, PBC. Then these three concepts are very important. Then one more factor is there. This is an inclined member. You know, we cannot find any force when you keep in the inclined position. So I said before, every inclined member has a horizontal component as well as vertical component. So we should mark the horizontal component and vertical component of at that particular inclined member. Okay, so first step is mark the horizontal and vertical of inclined member. These 4 points are very important. Okay, so we are going to use these 4 conditions in the entire unit. Okay, so better to keep in your mind these 4 concepts are very important and essential. Okay, and how will you make the horizontal component and vertical component? You can give the arrow like this. Okay, how will you give the name of this component? This is the PBC. Okay, here theta is acting here, right? This is and we already know this the angle of inclination of the inclined member. So similarly this angle is also 30 degree. So we can also write like this: PBC cos 30 degree, because theta is lying in this direction. Say where the angle is lying. Depending upon the angle, we can give the cos theta and as well as the sin theta. Okay, so this is the PBC cos theta, this is PBC sin 30 degree. Is it clear? So it's a very important thing. So this is the angle of inclination. So this horizontal component is cos theta, vertical component is sin theta. Okay, then what will you do? How can we find the forces of every member? So first our condition, summation of vertical force equal to 0. This is our first condition. Okay, summation of vertical force equal to 0. So how many numbers of vertical components are over there? Just think about that. Here only 2 components. Okay, here this is the first one, this is the second one. Here another one important thing is unit conversion. Okay, if you consider, or else when a force is acting towards the upward direction, you should consider positive sign. If the force is acting towards the downward direction, you should take negative sign. If the force is acting towards the rightward direction, you should take the positive sign. When you force is acting towards the left side direction, you should consider negative sign. This is the another one important factor. Okay, so very important thing. Then here 2 forces are acting. One is acting towards the upward direction and another is acting towards the downward direction. How can you write here? So this PBC sin 30 minus 15, clear? That is equal to 0, because this force is acting towards upward, this force is acting towards the downward direction. PBC equal to 15 divided by sin 30 degree. Okay, then so PBC, what's the value of PBC? So PBC is 30 kilonewton. Here we get the positive result, so we can easily get the conclusion this member, that means PBC is the tension member. Okay, PBC is the tension member. The very important thing is, if we get the positive result, that means our assumption is right, answer also right. What is our assumption? We assumed before this member is a tension member, right? The tension member. So we get the positive result. So we can get the conclusion this PC member is tension member. Then second thing is, second and one more member is there, right? We should find the force of that member. That means that you can also write like summation of horizontal force equal to 0. How many numbers of horizontal force over there? There are 2 forces, right? One is PA, but which is acting towards the upward direction. So you should write like this. You should put the negative sign. PBA. Again one more force is there, that also acting towards the leftward direction. So minus of PBC cos 30 degree equal to 0. Here already you know the value of this PBC, right? So you can substitute over here, PBA minus 30 into cos 30 degree equal to 0. So when you calculate this time, you will get the value like minus PBA minus of 25.98 equal to 0. So minus PBA equal to 25.98. So PBA equal to minus 25.98 kilonewton. So you may think like that we get the negative result. So you may think that oh, my calculation is wrong. It's not like that. That means this negative symbol represents that answer is right, but our assumption is wrong. What we assumed before, we assumed that tension force which is acting on at this member, but when you solve these things, we get the negative sign. That means our assumption is wrong. That means here in this member, this P and that BA, this member which is carrying the compressive force. Okay, this BA member which is carrying compressive force. That's all about the problem, and thank you for watching this video.